Welcome. I'm going to have a run through 91579 Level 3 Calculus 2025 examination. Apply integration methods to solving problems. I don't need to scroll. Set this up differently. So question 1 is find the integral of sec 6 times sec 3x tan 3x. The first thing to do with this sort of problem is to connect my writing device, is to write u equal to 3x. That will simplify these a little bit. I'll look at this more generally just straight after doing this question. When we do that substitution, we get du equals 3 dx. Since we've got dx over here, it's perhaps more useful to rewrite this as dx is du divided by 3. So we can put in place in this integral dx, we can put du divided by 3. So what our integral then becomes is becomes the integral of 6 sec 3x is u, tan 3x is still u, and dx is du over 3. Well, 3 goes into 6 twice. And you need to recognize that this sec u tan u is just a standard integral, and it is the integral of sec u, or another way, differentiating sec u, you get sec u tan u. It's in your tables, you can look it up. There's a 2 in front, and we have to add a constant of integration. And after you do a substitution, when you finish or before you finish the problem, at the last step, you substitute back for your u, and this will give us a final answer. This sort of substitution comes up a lot, and you can possibly avoid doing it by just knowing a general rule. If you have an integral, say of f of well, just a constant in here, ax plus b, a constant times x, a linear term basically, if this is linear, then by doing the substitution u equals ax plus b, then you get du is equal to a dx, or dx is equal to du divided by a. Then this integral becomes the integral of f of u du divided by a. And what that means is that when we have a linear term in here, we want to not turn on our eraser and show that it's a linear term. When we've got a linear term in here, you can change it to a simpler integral with just a standard variable, just by dividing the whole thing by a. So you do the simpler integral and then divide the answer you get by a. And this comes up a lot in this examination, and I might use this shortcut other times. So the shortcut, if I was to use the shortcut on this method here, I would just say, oh, look, I recognize sec times tan. The integral of that is sec, so I'm going to get sec 3x. It's got a 6 in front. I have to divide by 3. Add the constant. Do the simplification, and basically I get the same answer in one step by knowing this rule. Linear term inside means I can just divide by the coefficient of x in the linear term. The b part plays no part, except that it would reappear in the final answer. We'll see some of those later in this examination. So that's 1a. 1b, solve the differential equation. When you solve a differential equation, it's basically an integration problem, and when one side of the equation only has one variable in it, and there's none of that variable on the other side. It's straight integration. So to find this, to find y, what we have to do is basically integrate 3 root x plus 2 over root x dx, and we put in our boundary conditions. I think it's easier to attack this if you write these as powers. So square root of x is x to the power of a half, and square root of x is still x to the power of a half. In the denominator it gets a minus sign as well, so x to the power of minus a half. And now we integrate this, and we use our normal power rule. So 3x, add 1, becomes 3 over 2, 1.5, divide by the new power, 3 over 2, plus 2x, add 1, you get a half, divide by the new power, and then add a constant. We can tidy these things up a bit. 3 over 3 cancels, and a half on the bottom becomes a 2. Divide by a half is the same as multiplying by 2, so you get 2x to the power of 3 over 2. Divide by a half, same as multiplying by 2, so you get 4x to the power of a half plus c. So that's our function. We are told that y, when x equals 4, is 10. Y equals 10 when x equals 4. This is 4, square root is 2 to the power of 3 is 8. 2 8s are 16. 4 square root is 2. 2 4s are 8 plus c. So we've got this. That means c is going to be, this is 24. Take that off, is going to be negative 14. And just checking what the question asks, solve the differential equation. So we've got to solve the differential equation. The solution is going to be our y equal to 2 x to the 3 over 2. You could leave that like that, or you could write it as x root x, or normally a normal power, I think, would be fine, but you're going to, if you wrote that as a root x, this would be okay as well, minus 14. So that's one way to write the answer. Leaving these as powers would be okay too. You should write out the whole equation, y equals, with the constant that you have found. So that's part B. Part C. It is given that some integral involving a and k and x squared, x is the variable, is equal to 3, and another integral that involves k and a, there's an equation with that, determine the possible values of k. So what we need to do here is just, these are definite integrals, we need to do the integrations and get equations and then see what that means for k. So the integral from 1 to 2 of a minus 6k, and I'm going to write this as x to the power of minus 2 as I write it out, dx. We know it's 3, but we're performing the integration here, so integrate a constant, a and k are constants, we just get a times x, and then minus 6k, add 1 to the power, becomes x to the power of minus 1, divide by the new power. Dividing by minus 1 is going to change this to a positive sign, and then we're done. And we want to evaluate that at 2 and 1. So if we put 2 in, we get 2a. 2 in here, that's going to be on the bottom. So it's 6k divided by 2. So plus 3k. And then subtract off, put 1 in, that gives us a. And subtract off, it's going to be 1 on the bottom, it's just going to be 6k, so minus 6k. So it looks like we get a minus 3k. And we're told that that's equal to 3. And now, if we do the other integral that we're given, the integral from 1 to k of 6x dx, this is like a power of 1, so we add 1 to the power, we get 6x squared, and divide by the new power, divide by 2. 6 divided by 2 is 3. And we want to evaluate that at k and 1. So that's 3k squared minus 3. And the question tells us that this is equal to a. So now we've got an expression for a, 3k squared minus 3, and we can put that expression up into this other equation. And then we'll have substituted out the a, and we'll have an equation that only involves k's. So it will become 3k squared. So therefore 3k squared minus 3 minus 3k equals 3. That's just a quadratic equation. Let's put it in the standard form. Well, actually, when we can notice straight away that there's a common factor of 3, so we can divide through by 3 and put it into standard form. We're going to get a k squared. Right, the k term next is minus k, and we've got minus 3 here, and minus 3, it's going to be minus 6 over 3, so minus 2. Minus 1 here effectively when we're divided by 3, and 1 here when we're divided by 3. So that becomes minus 1, and that will be equal to 0. That's the standard form. That's got an easy factorization. Minus 2 times 1 equals negative 2. Minus 2 plus 1 equals minus 1. So that works. So we've got k equal to 2 or k equal to negative 1. Was there any conditions on them? A and k are just constants. Determine the possible values of k. So we've found that, and that's all we need to do. It doesn't ask us to find a, but we could find a very easily. Here's an expression for a. So we could say, in this case, a equals 3 times, I'm writing 4, which is okay, but I was intending to write 2 squared minus 3. 4 3s are 12 minus 3, a will be 9. And in this case here, a is equal to 3 times minus 1 squared, minus 3. Minus 1 squared is 1. 3 minus 3, that's 0. So we could find a as well, but the question didn't ask for that. So up to this hash is all that's needed to answer that question. D. The graph below shows part of the graph of the function y equals 4 sine 5x cos 3x, and it wants us to find the shaded area under the curve between x equals 0 and x equals pi over 6. That's straight application of integration. The so the integral of 4 sine 5x cosine 3x dx is going to be equal to the area, which is what we want. When all the graphs above the axis, if you had bits that were below the axis, you might have to do some adding and subtracting to get the actual area. So that's telling us that the integral is going to work for us. We don't know how to integrate this directly, but we have some nice trig identities that help us with this. And the trig identity that helps is sine A times cos B is equal to a half sine A plus B plus sine A minus B. So if we've got sine A cos B, it's equal to half the sine of the sum of the two arguments plus the sine of the difference in the two arguments. You don't need to remember these. They're in the tables for you to refer to. But it's a good exercise if you know sine A plus B, which is also in the tables. That's sine A cos B, and then plus sine B cos A. And then if you rewrite that out with a minus B for this term here, you get sine A cos of minus B, and plus sine of minus B cos A. And it's a property of cosine that if you negate the angle, it doesn't change. Cosine curve goes like this, recall, and it's got the same shape going backwards. So if you have the negative angle, it's got the same cosine as the positive angle. So we can write that as sine A cos B. Just get rid of that minus sign. And for sine's got the opposite sort of property. When your sine graph goes like this, and when you negate it, so the positive value has got a sign, the negative value has got the negative of that sign. So so this one becomes minus sine B cos A. And now if you add these two together, you get sine A plus B plus sine A minus B. And that's equal to this one and this one are the same. So you get 2 sine A cos B, and this one and this one are the same, but they differ with a minus sign, so they just cancel each other out. And effectively this here gives us this formula. So all of these formulas are in your sheet. You don't need to remember them, but it's a useful exercise to do the algebra and derive the formulas, one from the other at least. And it will improve your confidence with algebra. And I think it's an interesting exercise. Anyway, back to the problem. We can transform our integral. So our integral, let's write it out down the bottom here, 4 sine 5x cosine 3x. Oops, D. We want to do that. The formula says that's half of the sine of the sum of these, so that's the sine of 8x, and then plus the sine of the difference, which will be 2x, 5x minus 3x, and then differentiate. Half of 4 is 2. You can take that outside. Integrate sine, we get negative cosine. It'll be 8x, and then divided by 8. That's that linear function rule. For linear function inside, we can just divide by the coefficient of the x outside. Same over here. Integrate sine, you get minus cosine, and this time we have to divide by 2. So that's all of those. And I didn't write in here, we're integrating from 0 up to pi over 6. From 0 up to pi over 6. We want to evaluate this from 0 up to pi over 6. And so this is 2 and times minus the cosine 8 pi over 6 divided by 8 minus the cosine 2 pi over 6 divided by 2, and then subtract, putting 0 in. Cosine of 0, it's minus cosine of 0 over 8, and then minus cosine again of 0 over 2, and that's done. This one's 4 over 3. You can do that on your calculator. You can get there with just a picture. Pi over 3 is this triangle, so cosine of pi over 3 is root 3 over 2. And then if you just look at the cosine graph, it goes like this, and there's a whole lot of symmetry, so pi over 3 is here somewhere, below pi over 2. So that's told us this, but here it's cosine is not root 3, I've done the sign there. Cosine of pi over 3 is 1 over 2. This is pi. 2 pi over 3 is here, that's got the negative, and this one up here will be 4 pi over 3. It'll have the same value, so it's the negative of this. So cosine of 4 pi over 3, you can see from the cosine graph, is going to be negative a half. So this is 2 times minus negative a half over 8 minus a half over 2 minus cos 0 is 1 over 8, and maybe I'll put a bracket around this, and minus 1 over 2. Hopefully I'm on track. So this is 2 minus is plus a 16th minus a quarter plus an 1/8 and plus a half. So half minus a quarter is a quarter, plus an 1/8 is 3/8, plus a 16th is going to be 3/8 is going to be 6/8, 7/16, times 2 is going to be 7/8, I think. And we're done. But you can check it on your calculator. 1e. Consider the differential equation. Now, unlike the previous differential equation, let's just go back and have a look. Here, where on the right-hand side were only x variables and there were no y variables other than the dy by dx. So we could just straight integrate. This question has got x's and y's mixed together on one side. The strategy when that's the case, if you can, you can't always, but if you can, is to separate the x's and the y's. So these two terms have a common factor of y, so that suggests taking that common factor out. We want to keep the x's and y's on different sides. This is a minus, so I'm going to make it plus on the other side. So this is going to be equal to 1 plus x dy by dx. And we can shift all of the x's over this way and shift the y's over this way. It'll be by dividing in both cases, so you get 1 minus x over 1 plus x equal to 1 over y dy by dx. And now we've successfully separated the variables. We've only got y's on this side, aside from the dx, and x's on this side. But when you get to this point here, when they're separated, you can solve this simply by integrating. So we just integrate. Before we do that, this one here is going to require some extra technique to integrate it. And we don't have like a quotient rule for integration, so we need to separate this into things that we can integrate. And the way that can be done is if we change that 1 to a 2 and take off a 1 and put it over 1 plus x. And leave the other same thing on the other side. We can then think of this as 2 over this, which is going to be straightforward, and we can think of this as minus 1 minus x over 1 plus x, and the numerator here is the negative of the denominator, so the second one is just going to become minus 1. So actually, let me take the liberty of shifting this to the other side. So 1 over y dy dx, we don't need to do this, is going to now be 2 over 1 plus x, and then minus 1. 1 minus 1 minus x divided by 1 plus x just becomes 1. And now we've got things that are easy to integrate. Integrate 1 over y, you get the logarithm of y. Integrate 2 over 1 plus x, that's also a logarithm. This is a linear thing, so when the coefficient's 1, we're just dividing by 1 at the end. So all you need to do here is 2 times the logarithm of 1 plus x. And when you integrate 1, you get x. And of course, we have to add a constant of integration. Now the question tells us when y is 3, that y is 3 when x is 0. So this will enable us to work out the constant. So y equals 3 at x equals 0. So that means that the logarithm of 3, the absolute value of 3 is 3, is equal to 2 times the logarithm of 1 plus 0 is 1, minus 0 plus c. Logarithm of 1 is 0, so both of these terms vanish. So that just says that c is equal to the logarithm of 3. So now we've got an equation that says the logarithm of y, absolute value, is equal to twice the logarithm of 1 plus x minus x plus the logarithm of 3. And the question says, what values can y have when x is equal to 2? So we've got the logarithm of y, absolute value, is equal to 2 times the logarithm of 1 plus 2. We've got x equals 2, that's what we're putting in, minus 2 plus the logarithm of 3. This is the logarithm of 3. It's 2 lots of that plus another lot of that. So we've got 3 times the logarithm of 3. And we've got minus 2 here. Everything else has got logarithms, so it's going to be useful to write that as a logarithm. So that's going to be minus the logarithm of e squared. The logarithm of e is 1, natural logarithm. So the 2 can go out the front. That's going to be the same there. I've got rid of that log 3. And our rules of logarithm, we can make this a power. So this is the logarithm of 3 to the power of 3, which is 27, and make this a division, e squared. Now we can take exponentials of both sides to get rid of the logarithm. I didn't write that very neatly. Not that I write everything else neatly, but at least hopefully you can read some of it. So that means the absolute value of x has to equal 27 over e squared, and that means that absolute value of y, I think I said x, that means that y is either the positive or negative 27 over e squared. You could get a calculator and put in the value of e and get an answer out of that, but I'm leaving it like that with a nice e number in there. Question 2. So again, using the rule that I looked at before, this is a linear term, so you can just treat this as one variable and just divide by 2 at the end. So to do this integral, it's something to the power of negative 6. It's on the bottom. If you wanted, you could write that out. So you could write it as 10 2x plus 1 to the power of negative 6 dx. and that's not a bad practice to get it into the normal power form. And the rule is add 1 to the power, becomes -5, divide by the new power, and because there's a linear term inside here, we have to divide by the 2. There's no rule if this is more complicated than linear, or no simple rule that we can use. So, and we've just done an integration, so we have to add a constant of integration. 5 times 2 is the same as 10, so these are going to cancel. We'll get -1 over 2x plus 1 to the power of 5 plus a constant. So there's our integral. Part B of question 2. The rate of change of a particular function is given by dp dt is equal to 5 cosine 4t. Find the function given that p equals 8 when t equals pi over 24. Okay, same theme. This is a linear function inside. We know how to integrate cosine. To find p when you're given the derivative, all you have to do is integrate. So p is equal to the integral of 5 cosine 4t dt, and integral of cosine is sine, so this is 5 sine 4t, linear function, so we have to divide by the 4 and add a constant. That's the integration done. We want the function, the particular function, when that has a value of 8 when t is pi over 24, so that enables us to calculate this constant. So we've got 8 is equal to 5 sine 4 times pi over 24 over 4 plus c. 4 goes into 24 6 times. Pi over 6 is one of our friendly triangles. Sine pi over 6 is a half, so we get 8 is 5 times a half divided by 4 plus 6. This is 5/8. So c is equal to 8 minus 5/8. This is 64/8, so 59/8. Write it as a decimal if you want. 7/8 to 56 and 3.375. Whatever you want. So we want the function, so I would write it as p is 5 sine 4t divided by 4 plus 59/8. My teachers told me that fractions are always exact, decimals aren't. This particular decimal is exact because it's an 1/8 fraction is exact to 3 decimal places, but I got taught to write answers as fractions, so I'm going to leave it like that. 2c, find the value of the constant k given that this integral from 0 up to k is equal to 1. Okay, again we've got a linear term inside and otherwise an integral that we can do. So the best thing we can do, I think, well, a good strategy anyway, very good strategy, is to rewrite this as a normal power. So 4x plus 1. It's on the bottom, so it's got a minus sign. It's a square root, so it's got a power of a half and dx. And as I said, so just use the normal power rule. Add 1 to the power. Divide by the new power. And divide by the 4 that's in here. And then evaluate at k and 0. I might do this one again with a substitution, so you can see that this will come out the same. So we get 4. Well, this is a square root, so we get the square root. You might want to tidy this up. 4 over 2 on the bottom is like divided by 2, so it's 4x plus 1, the square root over 2, evaluated at k and 0. So it's the square root of 4k plus 1 over 2, and then subtract, put 0 in, get the square root of 1, so it's subtract 1 over 2, and we're told that that's equal to 1. Add a half onto the other side, you get 3 over 2, multiply by the 2, you get 3, so we get root 4k plus 1 equals 3. Square everything, 4k plus 1 equals 9, take off the 1, 4k equals 8, so k equals 2, and the question said find the value of k. Just the integration, if we go back and do that again, so if you did it by substitution, you could put u equals, well actually you can substitute the whole thing. You can substitute just u equals 4x plus 1. And it's a good strategy actually to doing these problems is to practice them, is to do them in different ways. You can probably also do this by substituting the whole integrand, so 1 over this by u, then you have a differentiation. Probably works, subtract 1, yeah, probably works. Might be a bit messy if you do that. Anyway, let's do this. Du, so we're differentiating. This is something to the power of a half. So we get a half, the same thing to the power of minus a half. That just means it's a square root on the bottom. And then differentiating multiplied by the derivative of what's inside, which is the 4. And then dx. So we've got a 2 here. And the beauty of this is all of this matches exactly all of this. So we can substitute out of all of this and then just get a du, and we just have to deal with the 2, which is just dividing on the other side. So now our integral becomes, the integral. When I do a substitution, I like to explicitly write, if I write the limits out without changing them, to write x equals k, x equals 0, because I don't want to be substituting those limits in for u as I do this. So all of this that I've circled in pink becomes du over 2. That's the easiest integral you can do. You just get u, or almost the easiest you can do, u over 2, and we're evaluating that at x equals 0 and x equals k. Since we haven't got x's, it's probably useful to put it back in terms of x. U is 4x plus 1, the square root, divided by 2, evaluated at k and 0, and we see that these two steps are identical. So you can do a substitution and you'll get to exactly the same place you got using the simple linear rule that I explained earlier in this video. So I won't do the rest of the work, but it's worth redoing these with trying some other substitutions as well. Often questions that succumb to substitution, more than one substitution will work, and it'll give you lots of practice on the same question and some reassurance when you get the same answer. So let's move on to part D, question 2, part D. A particle's acceleration can be modelled by some equation. It says initially at a fixed point P, the particle had a velocity of 6 meters per second. How far from the point is the particle? So we've got acceleration. Let's actually highlight it. We've got acceleration, we've got velocity, and how far is the point? So this is a displacement. where A of t is the acceleration of the particle and t is the time in seconds from the start of timing. So acceleration to velocity to displacement. We integrate, which isn't surprising because we're doing an integration examination. If you were going the other way, then you would differentiate. So you could get these mechanics type questions in differentiation or an integration examination. Anyway, so we've got an equation for A. So to find V of t, that's the integral of A of t, which is in our case the integral of 2.4 e to the power of minus 0.3 t minus 1 dt. This is one of these linear bits inside a function again, so we can just treat this as e to the t, similarly to e to the t, and then divide by the minus 0.3, the coefficient of the linear part of the variable part when we do the integral. So we get, integrate this, you get 2.4 e, exponential stays the same, divide by the minus 0.3. You could do that step by substitution. Integrate 1, you get minus t. And any indefinite integral, you add an integration constant. So v of t is this. This is 24 divided by 3. This is going to be 8 with a minus sign. Yep. And we're told that the velocity is 6 initially. Initially means t is 0. So the velocity when t is 0 is 6. And that's going to be equal to negative 8 e to the power of minus 0.3 times 0 minus 0 plus c. Exponential to the power of 0 is 1, so this is minus 6 is equal to minus 8 plus c, therefore c is 14. So now we've got v of t equal to minus 8 e to the minus 0.3 t minus t plus 14. We want displacement. Displacement in these physics type questions is often written as an S. That's in deference to us mathematicians, because d for displacement or d for distance doesn't work when we're doing derivatives, where we often use d as, you know, so dd by dt to get velocity would look funny with two d's there. So hence the physicists use S. So we want to integrate the velocity with respect to t. Same thing, this is exponential, which stays the same. It's got minus 8 in the front. We have to divide by the coefficient of t in there. Integrate t, we add 1 to the power, divide by the new power. Integrate 14, becomes 14t, and then plus a constant. And we're a distance from a fixed point, initially from a fixed point, so we can call that point the point where s equals 0. We're basically free to choose where our frame of reference starts. So we s equals 0 at the time t equals 0. So initially we're at a fixed point and we'll measure all our distances from the point P. So we can now use that to find our constant here. Actually, it's a bad practice. I've used C up there. I should change this and call it K, say K for this constant. So S of naught, I want to be naught, and it's going to be minus 8 over minus 0.3 e to the minus 0.3 times naught minus naught squared over 2 plus 14 times naught plus k, and that means well, 8 divided by 0.3 doesn't have a nice number. This bit here is 1 though. Exponential to the power of 0 is 1, so we get 8 over 0.3, 80 over 3. Negative signs cancel, so naught is equal to 80 over 3 plus k. So k is negative 80 over 3, I suppose. So that means our distance at time t is 80 over 3 e to the minus 0.3 t. I'm reading from up here. Minus t squared over 2 plus 14t minus 80 over 3. And the question asks us to find how far it is at time 3. So S of 3 is 80 over 3 e to the minus 0.3 times 3 minus 3 squared is 9 over 2 plus 3 times 14 is 42 minus 80 over 3. Here's the difficult bit. I guess you have to use a calculator there. Just see, I think I've done the calculation somewhere. Yeah, I got 21.7. 21.7 meters after 3 seconds. Part E, the graph below shows the function y equals sine cubed x cos cubed x. Find the shaded area under the curve between the values x equals 0 and x equals pi over 2. Well, this is just a straight integration question. So we want to find the integral from 0 to pi over 2 of sine cubed x cos cubed x. Now this looks messy. We don't have product rules and we don't have normal composite function rules. We've got a sort of a composite function, two composite functions multiplied, a cube inside or outside a sine and a cube outside a cosine. We don't have rules for that. So we have to use substitution. Again, there's many substitutions that work on this. You could try u equals sine cubed x. You could try u equals sine x. You can try u equals cos cubed x, and probably sine squared and would work as well, and cosine. So there's 3, and there's many more others. I'm going to try this one. What often happens when you do try different things, if you try a more complicated substitution, well, you get a different integral to do. Oftentimes, it's the more complicated the substitution, the easier the integral will become if they still work. I don't know that actually works so well here, so they were just suggestions, hence the different colour. So we're going to do u equals sine x, and what happens then when you differentiate that, differentiate sine, you get cosine. So cos x dx is du. So I can get rid of one of these cosines just by the change of variable effectively. So this becomes the integral. We'll write x equals 0, x equals pi over 2. We've got sine cubed x. We're going to have cos squared x, and the cos x and the dx are going to be replaced. Cos x and the dx are going to be replaced by du. So I've changed the variable, but I haven't changed these two bits here. That's more for explanation purposes. I perhaps wouldn't normally do that if I was just doing the problem. Sine is u, so sine cubed is u cubed. Cosine squared, side work, is 1 minus sine squared. That's a identity that we have. Cos squared plus sine squared equals 1. Can be rearranged like this. So cosine squared is the same as 1 minus u squared du. So now we've changed our integral from trigonometric product, trigonometric powers product, into ordinary powers and sum or difference, because this we can multiply this out. And let's do that. U cubed minus u to the power of 5 du. Both of those integrals are easy. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And we want to evaluate still at x equals 0 and x equals pi over 2. We've got u's instead. Remember, u was sine x. So this is sine to the power of 4x over 4 minus sine to the power of 6x over 6. And we're evaluating that at 0 and pi over 2. Sine pi over 2 equals 1. So we're going to get 1 to the power of 4. It's going to be 1 over 4. 1 to the power of 6 minus, and put sine as 0 at both of these, so it's just minus 2 zeros. 6 minus 4 is 2 over 24, which is 1 over 12. And we're done. Find the shaded area. Question 3. The diagram below shows the cross-section of a hole dug in the ground. The depth of the hole is measured every 5 meters across the top of the hole. Using the trapezium rule, find an estimate for the area of the cross-section of the hole. So the trapezium rule is basically each of these regions where I'm not drawing very well. I'm probably as worse than the curved line that's there, but basically we're making a straight side, so we're making each of these do a different color. We're approximating each of these by a trapezium, and the area of a trapezium is a half the two sides that are different. You add those up, 2.12, and I've done a bad thing by writing over the top of that, 2.32, and then multiplied by the height, which is 5. Now, our trapeziums are lying on their side, so that's the area of a trapezium. It's like a triangle formula. I mean, a trapezium is really a cut-off triangle, so that's why they are similar. And we just add these up for all the trapezium, or trapezia. And you can see that these sides in the middle are going to get doubled up because they will be part of two trapezia, and the ones on the outside, they will only occur once. So you can look the formula up, but the trapezium rule says the area is equal to 1/2 times this interval length, which I think they call h. So h over 2, and times the first and last, 2.12 plus 1.88, plus 2 lots of all of the others. So the formula is provided, and it's very easy to understand intuitively when you know what a trapezium is and how they're doing this, and so you're getting an approximation, so you add that up. And I'm not sure that I've added this up, but I can have a look and see. Oh yeah, no, yeah, I got 47.55. I didn't write. Our h is 5. I started off doing this by explanation and then actually solved the whole problem there, so I should have perhaps changed back to the other colour because I've done explanations in one colour and working in a different colour. So this is really, this looks like red, but it's really pink. And this will be, I suppose you should put units on metres squared. Question 3, part B. Another linear function. So this integral is the integral from 1 to k, 10 to x minus 1 to the power of minus 1 dx, and we can just use the power rule. Give your answer in terms of k, where k is a constant and k is bigger than 1. So when you've got a power of -1, adding 1 gives you 0, dividing by 0 you can't do. That should be a trigger to remind you that when it's just 1 over something, you get a logarithm. So here we get the logarithm of 2x minus 1. And linear term in here, we have to divide by that 2. And this is a definite integral, so we're evaluating at k and at 1. So this becomes 10 over 2 is 5. The logarithm 2k minus 1, and then minus, it's still going to be 5 out the front, the logarithm 2 times 1 minus 1. Logarithm of 1 is 0, so we just get this term here. You don't need absolute value because k is bigger than 1, so this will always be positive. So they've got this condition to make sure that you always get a positive number in here. They could have got away with just k bigger than 1/2, couldn't they? Because 1/2 of 2 is 1 minus 1 is 0. So as long as you're bigger than that, you're going to have a positive number here. And I will stop. Okay, this is a continuation of the video solutions. Got interrupted yesterday. It'll be merged into the same file. So to have one file with the whole examination in it. So let's have a look. This is another differential equation. It's a separation of variables. So the idea is we want to shift the y term on this side and just have x terms over on the right hand side. And yeah, so let's just do that. You'll get dy divided by the square root of 4y plus 1 equals dx over x squared. And you could integrate both of these expressions. I think it's helpful to rewrite the 4y plus 1 as a power. It's a square root, which is a power of a half. It's in the denominator, so it's negative 1 half dy equals, same with the power here, you could write that x squared, x to the minus 2 dx. Maybe it's easier to cope with x to the minus 2 by itself because it's something that we get quite often. So just do normal integration, add, this is a linear thing, expression inside it again, so we can use our trick of just dividing by 4. Add 1 to the power, you get 4y plus 1 to the half. Divide by the new power, so we're dividing by a half, and we're also dividing by 4. And that's equal to, add 1 to the power is x to the minus 1, and divide by negative 1, same as just getting a minus sign, and add a constant. You only have to add constants to one side of these equations. If we had a constant on both sides, we could just shift one of them to the other side and combine the two constants to get one. So yeah, that's the integration done. We can determine C by just putting y equal 2 and x equal to 2/3 into this equation to see what happens. So y equals 2, x equals 2/3. What do we get? We get 4 times 2 plus 1 to the half, square root. 4 over 2 is 2, so it's all over 2, is equal to minus the reciprocal, so minus 3 over 2 plus c. 4 2s are 8, plus 1 is 9, square root is 3, so this is 3 over 2. Shift that over, plus another 3 over 2 equals c, so therefore c is equal to 3. And now we've got this, we want to find out what x is, what y is when x is 4/5. So now when x is 4/5, we get square root 4y plus 1 over 2. That's what we've got on the left-hand side, is equal to negative 4/5. The reciprocal was going to be 5/4 plus 3. This is 1 1/4, so this is going to be 1 3/4, so it's going to be 7/4. Multiply by 2, so we get square root 4y plus 1 equals 7 over 2. Square everything. 4y plus 1 is equal to 49 over 4. Subtract 1. 4y is equal to 45 over 4. And divide by 4. Y is equal to 45 over 16. You can write that as decimal if you want, but I'm going to stop there. I was trained to leave things as fractions in their simplest form. Part D. Just going to re-record the solution to this equation. I didn't do anything wrong in getting the solution. Well, I didn't get a wrong solution, but I wrote one line of working, which I hate. So I'm redoing it. So this question says we've got a graph of x squared plus 6 over x to the power of 4. And it shows a shaded region between p, x equals p and x equals 2p. Tells us this area is 9 over 4. That'll be the integral simply of this function. And it asks us to prove something about p. So all we've got to work with is that area, which is the same as the integral from p to 2p of x squared plus 6 over x to the power of 4 dx. We're told that that's 9 over 4. So let's work with the integral and see what we get. So we can with this sort of integral, we can split this up into x squared over x to the power of 4 and 6 over x to the power of 4. So that gives us the integral from p to 2p, x squared over x, I'll do it slowly, plus 6 over x to the power of 4. And we do that because we can, once we simplify this first one, we can do both of these integrals in a straightforward way. So this is the integral from p to 2p. The combined effect of this is x to the power of negative 2, 2 minus 4. It's 4 on the bottom, so this is plus 6x to the power of minus 4 dx. And these are straightforward power rule applications. So add 1 to the power, you get x to the minus 1, divide by negative 1 will give us a minus sign. Add 1 to the power, x to the minus 3, divide by negative 3, we're going to get a negative sign, and 6 divided by 3 is 2. That's the integration done. We need to evaluate at the limits of the integration. So we just put 2p in, we get minus 1 over 2p, and then minus, this one's 1 over 2p cubed, and then subtract, putting p in, it's minus 1 over p, and then minus 2 over p cubed. We can tidy that a little bit. It's minus 1 over 2p, minus 1 over, I wrote 1 on the top there, but this has got a 2 in it. So I avoided one mistake, and I'm writing another mistake instead. This one's not as egregious, so 2 over 2 cubed is 8p cubed. Then minus minus, it's plus 1 over p, and minus minus, it's plus 2 over p cubed. And as we noted at the beginning, this is equal to 9 over 4. Now, if we multiply this whole expression by 4 over p cubed, note we can do a simplification here. 4p cubed is the common denominator. We'll get rid of all of the terms on the bottom. So the thing that I hated is I wrote equals on the next line, but I'm multiplying through by this value here, so it's not going to be equal. So let's write it over here to emphasize that it's not a continuation of this equation. It's a new equation based on multiplying that previous equation by 4 times p cubed. So if I multiply this by 4 times p cubed, 4 over 2 will be 2, p cubed over p will be p squared. So I have minus 1 over p squared. This one, it's got 4p cubed in the denominator. I'm just going to lose that, so I'll just get minus 1. This one, I've got just a p in the denominator, so I'll end up with plus 4p squared. And this one, I've got p cubed in the denominator, so I'm going to end up with 8. And equal to, I've got 4 in the denominator, so I'm going to end up with 9p cubed. Now I'm just going to collect terms on one side together and have an equation equal to 0. So shifting all of these terms on the left to the right, and then I'm flipping it around and writing this right-hand side on the left. So I wrote, I'm really going badly here. So multiply this by 4p cubed. Divide by 2, you get 2. P cubed divided by p is p squared. So this should have been p squared, not a fraction. And it should have been 2p squared. Multiplied by 4, 4 over 2 is 2. So I've got minus 2p squared plus 4p squared. That's going to be 2p squared, but remember I'm shifting to the other side, so that becomes minus 2p squared. Here we've got 8 minus 1 is 7. Shift, it's going to become minus 7 equal to 0, and that's precisely what was required in the question. So we're done. And that's the error correction. Final question, part E. We've got a bit of art. There's a curved edge that's got an equation, x squared plus 3 all squared, and then multiplied by 1/3. And this guy Murray has apparently figured out through some research that if you calculate an x value based on this formula, you'll get a place where this will hang nicely. Use this formula to find the x value of the hanging point. So we've got two integrals, so if we just calculate those, we will then be able to calculate the ratio. So let's just go about doing that. So might be up too high. Integral from 0 to 3 x times 1/3 times x squared plus 3 all squared dx. That's the integral from 0 to 3. You can put the third outside. Got an x here, x to the power of 4 plus 6x squared plus 9, multiplying out that squared, so that's a third. The integral from 0 to 3, x to the power of 5 plus 6x cubed plus 9x dx. That's a third. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And we're evaluating that at 0 and 3. This is a third. Put 3 in, we get 3 to the power of 6 over 6 plus 6 times, well, we can simplify this. 3 times x, 3 times 3 to the power of 4 over 2, so we've cancelled this down to 3 over 2, plus 9 times 3 squared is another 9 over 2, and then subtract. When we put 0 in, these are all going to be 0, so that's all done. We can divide each of these terms by 3, so we'll get it divide by 3, they'll cancel the 3 here. This will become 3 to the power of 5, but this is 2 times 3, so this will become 3 to the power of 4, and this becomes 2. So we've divided this by a 3 here and a 3 here. So we get 3 to the 4 is 81 over 2 plus 81 over 2 plus 27 over 2, which is 81 and 13 and a half. So that's 94.5. For that integral, the integral from 0 to 3, supposedly the simpler one, of 1/3 x squared plus 3 all squared. We've already done that expansion, so let's just skip to what we know and have already done. So we have to calculate this integral. It's a third. Add 1 to the power, divide by the new power. Add 1 to the power, you get 3. Divided by 3, you get 2x cubed. Add 1 to the power, and the power is 1, so that's all done. And this is again evaluated at 0 and 3. This becomes 1/3. This is 80, well, the 3 actually cancels, doesn't it, and do everything again. So we cancel that 3, this will become a 4. This will become, oh, we haven't got a 3. that's bad. We haven't got a 3. It's not until we put the 3 in. We've got 3 to the power of 5 over 5 plus 2 times 3 to the power of 3 plus 9 times 3. And then take off a whole bunch of zeros again. Now we can cancel 3's into here. That reduces that to 4, reduces this to 2, cancels off here. So 3 to the 4 is 81 over 5. That'll be 16.2 plus 9 2's are 18 plus 9 is 27. 27, 16.2, 43.2. And our x value, I'll call it capital X, is, we're told, the ratio of these two things. You can just throw that into your calculator, but it's actually tractable in your head. So if we just multiply both by 10, we're not dealing with decimals. It doesn't make much difference. Now we can see some factors. There's a clear factor of 9 in the top. 9 times 1 is 9, and 9 times 5 is 45. And a factor of 4 here, times 108. 4 is going to 4 once, not into 3, but into 32 8 times. 105 is 5 times 21, and 108, it's got another factor of 4. 4 times 27. 27 cancels with 9 and 3 of these to give 7, so we get 35 over 16, which is 2 and 3/16, which you can work out as 2.1875. I don't actually know that. I pretty much did it in my head just then. I know that 3/8 is 0.375. That's a common one. So 3/16 is half of that. Half of 37 is 18, 1 over 75. And we're done, and we didn't use the calculator on the last question. So any questions, just put them in the comments and I will try and answer them. And otherwise, I'll see you next time. I've completed all of the level 3 calculus exams and the scholarship calculus exam. So we'll look at, I've got level 2 algebra that I might look at, and then I'm going to go back and look at 2024 and before and make some videos up for those. So anything you've got that you'd like me to cover, let me know and I might be able to prioritize it. Anyway, thanks for watching and see you next time.